Hello everyone, myself Arya Krishna. So today I have made a project on Coursera on machine learning. So in this model, we are going to predict the electrical energy output of a combined cycle power plant. So in so I have made this whole project on Excel. So in Excel, I have used two models to predict the target variable. I have used two models because it would help me to get to know that which model is better at giving predictions on the target variable. So in both the models, in model 1 and 2, the modeling approach that I have used is regression. As we are predicting a continuous value, and our target variable is the net hourly electrical energy output, that is PE. So the regression modeling approach is obvious. The features that I have used in both the models are AT temperature in the model 1, AT temperature, exhaust volume V, AP ambient pressure, RH relative humidity. In model 2, I have used AT, V, RH, the three features that I have used in model 1, and the fourth feature, that is AP, I have removed from the model 2 in order to make a difference between the models and finding out which model is better at giving the prediction for the target variable. So the algorithms that I have used in both the models are linear regression, as it is a built-in manually in Excel and it is a formula-based prediction. So in the model building process in model 1, I have used all the four features that have been given in the dataset. And in model 2, I have used three features and the fourth feature, that is AP, is removed from the model 2. So in terms of data split, out of all the 100% of data, I have removed 12% of the 20% of the data as a test set that I will use after finalizing the model. And apart from the remaining data, 20% of the data is used for validation, that is to compare the models, and 80 and the remaining, that is 80% of the data out of the training data, will be used for training the model, and it will be the same for both the models. So the metric I have used for validating the error in both the models is RMSE, that is root mean squared error. RMSE is suitable because it is sensitive to large errors and it keeps units same as the target. Like for example, in this the target unit is megawatt MW. So if I have used MSE, that is mean squared error, so our unit would be megawatt square, and it is not quite interpretable. So that is one of the reason I have used RMSA, because it has a root over it and ultimately our unit will be same, that is megawatt. So here you can see this is model 1 in which we have ATV, AP, RHP, and this is our summary output based on this data. Okay, so this is our data and this is our summary output. Now here I have found the RMSE, the error and everything. So here you can see PE. This is the original value that have been given to us from the data, and this is the predicted, the formula that we have used, in which there we have used the slope and everything, that is, you can say intercept and all these things. So based on that we made a formula and we have applied the formula, and these are our predicted values. So here in AF column we have subtracted the predicted and the original, and then we have squared this error, and then we have put the squared error answer into the formula. This is our formula: squared, under bracket, average, under bracket, for example F9. So here the values are different, it is AJ or AH, but it is a general formula, and this is our RMSE, and the total RMSE based on this formula is 2.195937. So this is the total RMSE of the model 1, in which we have used all the features. So this was our validation set on which I have found the RMSE, and this is our training, and this is the summary output we got after training our data, and this is the validation. on which we found the RMSE, the performance of the model. Now, if we go to the model 2, in which we have only used three features and we have removed AP. Here you can see this is a training data, and this is the summary output based on that training data, in which we can see the intercept, the slope and everything, and the R square, the summary output. So in the validation set, after applying all those formula, after finding the predicted value, the square error and RMSE, and applying all the formula, we can see our prediction is 2.196922, which is greater than in the model 1. So the RMSE in model 2 is greater than what we have found in the model 1. So we, up on this basis, we can say that the model 1 is performing better than model 2, as the root mean squared error is less in model 1. So uh, by all this we can finalize our model 1 as our final model. Now I have separated 20% of all the data as test data. After finalizing our model, we will use that data to finally predict our values to see that is it going good at after training all the data. So in RMSC, so finally we have finalized our model 1. Now if I scroll a little bit further, so here it is a test data. So here you can see the ATV, APRH, this is our model 1. It is P, the original value. So this is a summary output based on this data, and on basis of summary data, the intercept and slope, we can find the predicted value based on the formula, the squared error, and finally the RMSE. So the RMSE for the whole test set is 2.130336, which is better than the validation set. So that we can say our model 1 is performing very good on the new data, that is test data, because our test data was not included in our training set. So here we can say finally that the conclusion is the model 1 is slightly outperformed the model 2, and in model 1 the test data, which is a new data to the model,